Hello. We're going to talk about one special type of organic reaction with alcohols, and that is the Grignard reaction. So let's talk how we make a Grignard reagent, and then we're going to give you examples of show the mechanism of the reaction, and then a few examples of synthesis. So that will be my goal in the next few videos. So let's see, how do we make a Grignard reagent? That reaction, we do an alkyl, we start from an alkyl halide, and then we make it react with magnesium metal, shiny and clean, and we do that with ether, and it's gonna be anhydrous, so no water there. And what that does is that you will insert a magnesium here, and that absolutely changed the polarity of the bond. Remember that here bromine is more electronegative than carbon, so this is delta minus, this is delta plus, so you will have a vector in this direction. However, when you insert magnesium, that polarity changes, and so much so that Grignard reagents behave almost as carbon ions, so as this was positive and this was negative, so almost like that. So that's what we're going to be doing. And most organic reactions, so you will prepare, if you don't have the Grignard reagent, you will prepare it. But essentially, when you carry out a reaction, say, with something like that, that is acetone, what this will do is do a nucleophilic attack over to this carbon, which is electrophilic. So you will do an attack over here, and you will make an alcohol. That's why I called that at the beginning. This is an alcohol reaction. So you're making alcohols using Grignards. Now you're attaching this fragment that has two carbons to the, again, we have here, remember, two carbons. All I did is insert the magnesium. And now you will be adding carbons to that chain. So I'm having now this, which is an alkoxide, and this is new. So the beautiful thing about Grignard is that allow you to make new carbon-carbon bonds. So we're adding carbons to that molecule, and this is this fragment here. And the second step is always protonation here of the alkoxide to get the final alcohol. And as you see here, we started with a ketone and we added those carbons, and starting with a ketone, you're making here a tertiary alcohol. And if you did that reaction, say with, now I'm going to use acetaldehyde this time, so you will do exact same thing. So let's do my attack. I'm just going to do in another color. I'm going to attack over my carbonyl carbon, which is your electrophile. And what you're doing again, you're adding this fragment. You're adding two carbons. Now I'm not throwing the hydrogen is there, that hydrogen here of the aldehyde, and that's a new alkoxide. But notice that after you add the water here, you will form an alcohol, but this time is secondary. So if you start with here, if you do the Grignard reaction over to an aldehyde, you make a secondary alcohol. If you started with a ketone, you make a tertiary alcohol. Now, Grignard reactions are powerful, and they are strong bases also, strong base and strong nucleophile. That's why we need to work with them under anhydrous conditions. In a second step, after this has reacted, is when we add the water. So if we don't do that, let me draw here what would happen if you make, let's see, we made your Grignard. Say that the ether is not completely dry, and you use normal ether, and it had some amount of water. What would happen is that if you have water, remember we said it's a strong base. Say that you have water here. Well, here you have your acid-base reaction, and you're going to form simply an alkane. Well, here in this case, that alkane is ethane. You're getting that hydrogen. So that will be a problem. That's why we need to work this condition, need to be anhydrous. Otherwise, in traces of that, you will have the acid base reaction and destroy the Grignard reagent that you need for other reactions. So now in other videos, I'm going to continue talking about that and how Grignard reactions can be used to react not only with aldehydes and ketones, but also with esters and carboxylic acids.